Hello friends, welcome to my channel. Today I'll be speaking on the topic, a popular mathematics topic which is normally seen and studied in the higher level as at the upper grade academically, and here we'll be talking of the topic ODE, ordinary differential equation. Now this is a topic that many people find it difficult to understand due to the complexity of the course, but if you sit down, if you calm down and follow the course bit by bit, you would tend to see that everything is really not what you think it is, but instead it is as easy as anybody, anywhere, everybody can know and do and solve as well. Well, first of all, we'll be talking of the formation of ODE. Now, when we come to formation of ODE, there are four things we need to have in mind. The first is we identify the number of arbitrary constants. When I mean arbitrary constants, I mean the alphabets, the alphabet that comes or that makes up an equation, any equation that you are being given. Something like, let me say we have an equation like y equals to a exponential raised to power 2x plus bx b exponential raised to power x plus c. Then our arbitrary constants includes a, b and c. So these are the arbitrary constants. Now, like I said, the first thing you do is that you identify the number of arbitrary constants. I mean arbitrary constants. Now, once you've gotten the number of arbitrary constants, just like in this equation, how many arbitrary constants do we have? We have 3 arbitrary constants. Now, since there are 3, the next thing you do is to differentiate according to the number of constants, which means that since there are 1, 2 and 3 constants, we are differentiating 3 times. And now let's do it. The first differentiation will give you 2a raised to power 2x plus b raised to power x. This is the first differentiation. Don't forget that you differentiate 3 times based on the fact that there are 3 constants, arbitrary constants here. Now the second differentiation will give you 4a raised to power 2x plus b raised to power ex. Then the third differentiation will give you 8a raised to power 2x plus bex. Well, I advise as we solve along, as you watch, you also get a paper and a pen with which you can be practicing it, understand, so that in case it will help you save data as well. So now we've been able to differentiate according to the number of the constants that we have, which in this equation we have 3 constants, and now we've differentiated 3 times. Okay, now the third thing you need to do is to eliminate all the constants. Now when it comes to eliminating all the constants, okay, first of all, let's do it. Consider, okay, let's call this equation 1, let's call this equation 2, and let's call this equation 3. Okay, considering equation 1 and 2 and equation 2. Okay, now let us subtract and subtract. Okay, equation 1 is what? Oh, let's put 2 first. Equation 2, which is y I is equals to 4ae raised to power 2x plus b e raised to power x. Now y1 will now give us what? 2ae raised to power 2x plus b e raised to power x. Now when we minus the both of them, what are we going to be having? So it now turn out to be yi minus yi will give you what? Will give you, looking at it, to give you just 2ae to raised power that's raised to power 2x. That's just it. Now at this point we'll call this equation 4. Equation 4. Okay, now to get the other side of it, now we consider equation, let's take 1 and equation 3. Consider equation 1 and 3 and subtract. Okay, equation 3 is yi equals to 8ae to raised to power x plus b e raised to power x. Yi will give you okay, 2a e raised to power 2x plus b e raised to power x. Now subtracting the both of them, now have yi minus yi, which will give you 6ae raised to power 2x. So this is what we've gotten for the second substitution, let's say elimination rather. So you call this equation 5. Okay, now let's see, considering equation equation 1. Okay, no, let's consider the equation 4 and 5 that we've gotten, the last two answers that we've gotten. Okay, let's consider equation equation 4 and 5. Then we'll multiply. Okay, so we consider equation 4 and 5 and multiply. That's you considering this equation here, the equation 4, and we'll come down to equation 5. We'll consider both of them. Now how do we do that? So let's take equation 4, which was brought. So the equations include, that's the equation for 4. Okay, the equation for 5 rather is yi minus yi will give you what? 6a e raised to power 2x. Now when we are talking of the other equation, which is the equation 4, what we'll do is equation 4 That's equation 4, which is yii minus yi, which will give you what? 2 2aex. But this time we are going to see a way through which we can make the both of them give us an equal, as in to be equal when it comes to their result. Now, since this will give us this and this is a higher number, now what we are going to introduce here, since already we were meant to have something like 2aex for this for equation 4. Mind you, this is 4, while this is 5. Now, since we are meant to have 2aex, now what are we going to introduce to that answer? What are we going to introduce to here to make it equals to this, which is 3? So it's just like saying 3 brackets. So when 3 multiplies this answer, well, it's like 3 multiplying 2ax, it should now give us 6ae raised to power 2x. So now we've gotten this. So we now open the brackets. So it will now be we'll now be having y I. We are minusing the both of them. So separating here from here, leaving this alone. So we'll now be having yi minus yi minus 3 brackets yii minus yi, close the bracket. We are going, okay. So next it will now give us yii minus yi minus 3 yii minus 3 yi, which is equals to what? 0. So from here, the next and the final answer I guess should be equals to yii. Then taking them based on their powers, you get minus 3 yii, then plus this plus 2. Oh, sorry, I guess this should be a plus, a minus rather. Then minus times minus will now give you a plus. Sorry, this is a minus. Okay, so plus, plus 2 plus 3y is power 1 or whatever, minus 3 minus y prime will give you plus 2y prime, which is equals to 0. And therefore this is our ODE. This is the ordinary differential equation that we'll be able to form from this. So this is just what we need for the formation of ODE.